chat and get into some questions. So the first one is solve trigonometric equations here, and we're going to work on all the solutions. And so there's a couple different ways we can visually look at this. You know, the one way I look at this, because we solved this in our analytic trigonometry portion, but you can look at like where this is the graph. And if you remember the tangent function here, you know, the tangent graph repeats on and on and on, right? So first of all, we know that when tangent of x is equal to a negative square root of 3, wherever that is, right? I just know that that is going to be an infinite number of solutions. Now, however, if we're to understand where these solutions are, the graphical approach is not really going to help us, but what can help us is understanding our unit circle. So remember, the unit circle is represented by those points where, let's do that again. All right. So the unit circle is represented by points that lie with all have a radius of 1. And there's basically 3 major points that we need to know, at least in this first quadrant here. And that is going to be the square root of 3 over 2, comma 1/2. We have the square root of 2 over 2, comma the square root of 2 over 2. And we have 1/2, comma the square root of 3 over 2. Okay, so basically those are 3 points, and you know, one thing when we're teaching this, we go through that. Now the next thing is we need to understand, well, what exactly is tangent representing, right? Tangent is representing the y-coordinate over the x-coordinate. So out of all 3 of these angles, forget about the negative for a second. Let's just figure out which of these angles gives us the value square root of 3, right? Which of these when we take the y-coordinate over the x-coordinate? Because remember, the tangent of any angle, right, is y over x. So here's the y-coordinate and the x-coordinate, and we need to figure out which one is going to give us the square root of 3. Now, hopefully you can just recognize here by at least kind of doing some math and to kind of simplify this, we can see that it's going to be this angle, which based on our unit circle is going to be pi over 3. Now the problem is though, that's a positive square root of 3. So we got to figure out when it's going to be negative. And what we can do is look at reflections here. So we know that that same angle, same reference angle of pi over 3, but in the second quadrant would be 2 pi over 3. And again, you can see that's correct because this would now be negative 1/2 positive square root of 3 over 2. Okay? And then we have this angle down here, which has the exact same reference angle of, again, pi over 3, but now it's going to be short of a revolution around the unit circle, which would be 2 pi over 3. I'm sorry, 2 pi. So therefore, in terms of thirds, that'd be 6 pi, so that's 5 pi over 3. And that point works, again, makes negative square root of 3, so that's 5 pi over 3 and 2 pi over 3. Okay. So what was I trying to do? Oh, okay, yeah, the coordinate point. So that coordinate point is 1/2, comma, negative square root of 3 over 2. And both of these, again, when you take the y over the y over x, you can see that's going to give you a negative square root of 3. So therefore, I can just say the solutions here is x is equal to this angle, which is 2 pi over 3, and this angle, which is 5 pi over 3. Okay, so these are our two kind of angles. Now, the thing to kind of know, this is a really bad tangent because if you recall, there's asymptotes for the tangent graph, and these graphs repeat. And basically what we need to see is the graphical approach is how often do these graphs, you know, how often do these points repeat themselves? And, you know, on our study of the graphs of tangent, we saw that they repeat themselves every pi. And let's kind of make sense of that. Like if here is a solution, right? This is an angle that makes that equation true. Well, if we add pi to that angle on the unit circle, obviously, like add pi to it, it's going to take you to there, right? You're going to keep on getting this point. On the unit circle, though, you can see if you add pi, it takes you there. You add pi again, it takes you there. So how many times could we add pi? Well, infinite many times. How many times could we subtract pi? Infinite many. So to represent that, we use a letter, and typically N or K or C is a letter we'll use. I don't even remember what I use in my class, so I'm just going to use N. So I'll say pi n, where n is going to represent any integer, positive or negative. Positive, it's going to represent going to the right, and negative would represent going to left. But since, again, tangent repeats infinitely,